Hello, Algebra 2 people. In the last video, I said I was going to say what my expectations were on this project. And I didn't really talk about expectations, but I did show you what I would do to solve that. And that's, I guess, what my expectations are. So when you solve that, if you had written out your solutions like what I did here, I would be able to follow your work. And so I guess that would be my expectation. So just kind of go through and do it the way that I did it and come up with the answers. And let's do the same with this video. Let's talk about the second problem on your project. And here's a similar one. This one says that an automobile manufacturer sells 3 models of cars and claims that their average highway fuel economy is 34 miles per gallon. According to the manufacturer's research, the actual fuel economy is normally distributed. Now, these are normal curves. That means that they're bell curves, right? So the test results are shown in a table below, and they give us what the model was. We'll just call them models A, B, and C, and what their average highway fuel economy was, as well as the standard deviation they came up with from their data. So they've done some of the calculations for us. It's normally distributed, and they gave us the mean and the standard deviation. So the question that we're supposed to answer here is to use the data to determine if the manufacturer's claim is accurate. So they're saying that they have 3 vehicles and that the average fuel economy on these is to get 34 miles per gallon on average with all of their vehicles when you look at the entire fleet. Let's start off by analyzing each of these models independently. So it's a normal distribution, so I'm going to draw my normal curve. Ta-da! So artistic. All right, so there's like a normal curve. And through the middle of it, right in the smack dab center of this, is where the mean is, okay? And for this first one, it said their mean was 36. I'm going to write that there. Where'd you get that information, Mr. Fokin? Well, if you go back here, it says this mean for model A here was 36. I'll label my chart here A. I want you to notice that the standard deviation was 2 miles per gallon. So that's 36. Now, 1 standard deviation away on either side. I'm just eyeballing these. And 2 standard deviations away on either side. Bam. That is to say that, the distance from the mean over to there is 1 standard deviation. Same on the other side. Boom, there's 1 standard deviation. And since the standard deviation was 2, 1 standard deviation above the mean would mean that that's 38 miles per gallon. And 1 standard deviation below would mean this is 34 miles per gallon. And we're not necessarily going to go any further than that at the moment because, pull this up, but boom. Keep in mind that if your data is normally distributed, that this is kind of what's going on. Forget about the particular section that's highlighted right there at the moment. Let's just look at the distributions. Notice that 1 standard deviation away, and disregard these numbers that are underneath. I just grabbed a standard curve, a normal distribution curve from the internet, and I'm just showing that here. But within one standard deviation from the mean down is 34% of the population, and within one standard deviation up from the mean is 34% of the population. So when you look at both of them together, 68% of your population is within one standard deviation of the mean, and that's kind of where we're interested in. That's kind of where I'm going here. So we're supposed to, if we look at the problem, try to figure out whether their claim is accurate, right? And so, because they're claiming that there's an average of 34 miles per gallon, if I look at my curve that I just made, that's not the one I made. That's the one that I was showing you. The one I made is there. All right. 34 is what we're interested in. So the question on this one would be like, what percentage of people or what percentage of the cars get at least 34 miles per gallon? And so that would be anything from here up, right? And remember, 34% of my population is in here. 34% of my population is in here. I don't know if I can. Let's make this smaller. Share the screen. That's what I say. 34% of my population is going to be in there. And then there's going to be another 13.5% that's in here. And then up here, there's an additional 2.35% that's within 3 standard deviations. And then there's another whopping 0.15% of the population that's above 3 standard deviations out that direction. The same thing happens over here, 13.5, 2.35, and then 0.15% of my population way down here, more than 3 standard deviations away on the left. Let's go back and look at this picture here, which, ignoring the numbers at the bottom, at least we can look at the percentages in these spots where the standard deviation breaks are. There are some numbers that I can add together. This point right here at 34 is this, and down, if I shaded this region, like what they've shaded on the graph, that's kind of why I wanted to use this one as well, represents the same shaded region that's on this picture that's over here, right? Ooh, I can almost like point to it. This picture here. This picture that's here has the same region as far as standard deviations shaded, and all we really need to do, similar to like the last problem, is say, well, I could add up all the numbers that are to the right, but I could also just take 1 minus all the numbers that are to the left of 34. So let's do that. Let's do, that's why I grabbed my calculator. Let's do 13.5. No, it's not even on. Let's do it with the calculator on. 13.5 plus 2.35 plus 0.15 gives us a grand total of 16. So if I did 1 minus 16, that leaves me with no. These are percentages, aren't they? 1 minus 0.16 leaves me with 0.84, or 84%. 1 minus 0.16 equals 0.84. 84% of the vehicles labeled as A should get more than 34 miles per gallon. That's pretty good. But wait, there's other vehicles. Let's do B. According to the data, shrink this out again. According to les data, Where is my data? There it is. According to my data, vehicle B's mean is at 33. So if I make a new normal curve, we get to be artists when we do this, right? So make a new normal curve. That mean here is 33, right? Because that's what the data is telling us. The mean was 33, and the standard deviation was 1. So one standard deviation up is at 34. One standard deviation down would be at 32. Hopefully everybody understands what I'm doing. You draw your normal curve and you put the mean in. The mean's in the middle. And then each standard deviation is away from there. You get used to like where those standard deviations probably are. We're not being super accurate when we draw them, but like when you look at this, on your curve as it starts going down, kind of like midway through your curve from the top to the bottom, right around there, you draw a line. That's one standard deviation away. Draw one on the bottom side as well as the top side. Then as your curve starts to flatten out, boom, there's another line that you draw. That's your next standard deviation. You see what I was doing here? I drew the mean. I drew one standard deviation. I drew the second standard deviation. Then you have a third standard deviation way out here somewhere. And we're just kind of like eyeballing where it's at. We don't have to be real precise because all we're doing is relying on this normal distribution to tell us what the percentages are for each distance away. And each time I draw a line, I'm one standard deviation away. Since the problem that we're working on tells us that we start at 33, one standard deviation away changes the value by 1 for this particular one, right? We're on B here. Mean is 33, standard deviation is 1. So when we draw our curve, we put the mean at 33, one standard deviation away would be 34, because one standard deviation for this one was 1, and so on and so forth. Now, think about what we got going on here. If I go, 2 standard deviations away and then 3 standard deviations away, I'm going to fill in these things. But above 34, there's only 13.5% that live in that region between 1 standard deviation and 2 standard deviations is 13.5% of your population. Where do I get those numbers? Well, it's right here. Beyond 1 standard deviation, there's 13.5% in that region. Now, the next one is 2.35%. 2.35%. And then beyond that is only 0.15% of the population. And so if we want to know for this second vehicle, right, vehicle B, I'm going to shrink this down. For vehicle B, what percentage of vehicles get at least 34 miles per gallon? Well, everything from here on up. So we're going to add those numbers together and go 13.5% plus 2.35% plus 0.15%. And you tally those up and you get 16. So what that says is that 16% of your vehicles that are vehicles B actually got 34 or should get 34 miles per gallon or better. Now, why did Mr. Fokin subtract the value from 1 here? Well, let's look at the difference. We were really trying to find what the area of this region, all this non-shaded stuff was. And to find that, what we could do is take the shaded region and subtract it from 1 to find out that 84% of our area was not shaded. Over here, we want this area that's above. So I'm going to shade the area that we actually want. It's this area that's up here. So we just have to add these numbers together. Now, why did I do it one way here and a different way here? I'm trying to save myself a bunch of addition. I could have said 34 plus 34 plus 13.5 plus 2.35 plus 0.15. Yes. My calculator would allow me to do that, but it was just faster to say, oh, let's calculate 3 zones and subtract them from 1. Hopefully you're understanding why you would do that. But I digress. Let's move on to C. There are 3 vehicles. Let's look at the third. Vehicle 3, if I draw a normal curve, back to drawing my normal curve now, has a median at 32. And it has a standard deviation of 2. So, drawing my curve, I put 32 at the median. Since the standard deviation is 2, up here we've got 34. Down here we'd have 30. I don't really need any other markings. I just know that 1 standard deviation away, it gets to 34. See what I'm saying? Double check my numbers. Start at 32. 1 standard deviation is 2 away. So do you recognize that this graph, I'm again going to look at the region that's up here. Aren't those going to be the same regions as we had up here? Yes, they are, which means for this vehicle, only 16% of the cars should get 34% or better, or 34 miles per gallon or better. All right, let's go back to what was our goal here. It just said, use the data to determine if the manufacturer's claim is accurate. Well, what is it that they said? They said, according to the manufacturer's research, their fuel economy, their average highway fuel economy is 34 miles per gallon. Is that an accurate statement? Well, I don't know. If we looked at this and said 84, I'm going to write down the numbers here. This is 84% of these cars. It's 16% of these cars. And it's 16% of these cars, right? What happens if we were to average these values? Let's just go, well, maybe they sell, approximately the same amount of vehicles in each category. What would the average become? Well, let's find out. 84 plus 16 plus 16 gives us 116. And if we divide by 3, that tells us the average is 38.7-ish. So they're saying that about 38.7% of their cars get 34 miles per gallon or better. Don't know. Does that seem accurate? What do you think? It seems like maybe the car manufacturers may be a little bit misleading. It might also be that the car manufacturer has a little bit more information than what we do. They might actually sell more of vehicle A than they do of vehicles B and C. And then when they say, oh, well, the average vehicle from our company on the road gets better than 34 miles per gallon. They might be true. That might be true. They're not that far off, by the way. If we're looking at here, we're saying that approximately 38.7, almost 39% of their vehicles seem to get 34 miles per gallon or more. That might be a reasonable claim. Might not be. What do you think? It's kind of your opinion here as well. So you should summarize what you think. Use the data to determine the manufacturer's claim is accurate. Do you think it's accurate? I might look at that and say, well, I can buy that what they say is probably kind of true. The data that they provided here doesn't necessarily support that too much, but it's not that far off. If you think about 100% of the vehicles, the middle would be 50%, and they're only 11% off of that, slightly less than 11%. So say what you want on your part. That's kind of how you do that. If you have other questions, email me if you're not in school. If you're in school, come see me, ask me more questions. Good luck with this. They are due on Friday, so make sure you get a good early start on them and get them in as soon as you can. Thanks. We'll see you soon. Bye-bye.